Good morning, boys and girls. Welcome to room 9. And today we are going to be working on a few things to get ready for our Unit 2 assessment this week. So grab one piece of paper and a pencil, and I'm going to share my screen with you. Now it's going to be a little tricky because we're going to go back and forth from different shares. Okay, so you should be seeing bird feeders at the top of your page. So bird feeders are $4 each. How much does it cost to buy all of the bird feeders? So look, 4, 4, 4, 4, 4, 4. So I can multiply 2 times 3 times 4. So go ahead and try to solve how much the bird feeders cost. And I'm going to get a new share and show you my piece of paper. So we're going to be back and forth on this. All right. Actually, I wonder if I can do this. Let me new share again. Go back here. Share. What if I took my visualizer? Can I? Woo! I really hope this works out. Oh, it's thinking now. Okay. Actually, I think this might work. Okay, sweet friends, you should be able to see my paper and the image on the screen. So number 1, I am going to draw a quick sketch, not that big, 2 down, 3 across, and each is worth 4. Four, 4, 4, 4, 4, 4. So hopefully by now while I've been doing all of that jabbering, you did 2 times 3 times 4. And when I think about 2 times 3 times 4, I know that 2 times 3 is 6. So we rewrite the problem. 6 times 4. Now, 6 groups of 4 is the same as 1, 2, 3, 4, 5, 6. I can skip count by 4s 6 times, or I could add them. I'm going to skip count because I've been learning my 4s, the double doubles. So Mary had a little 4, 8 and 12, 16, 20, 24 and 28, and then it keeps going. But we know that 6 groups of 4 is 24. So my answer is $24. Writing it out like that is acceptable, or using the dollar sign, 24. And you could even put the decimal point to show that there's no cents. All right, let's look at number 2. The second one, okay, hopefully you still see the screen and my paper. And so I'm going to try to zoom in on this. Number 2, it says blank times 3 is 18. Well, the first thing over here in the box, it says list all the multiples for 3. So I'm going to sing my 3 song. 3, 6, 9, 12, 15, 18, 21, 24, and 27, 30, 33, 36. I know this is 10, 11, and 12. I'm looking for something times 3 is 18. So I can count 1, 2, 3, 4, 5, 6. 3 times 6 is 18. So 6 times 3 is also the same as 3 times 6, which is the commutative property. And 6 times 3 is the same as 18. So I forgot to mention that you should also be writing all of this down. So if you've just been listening, that's okay. I want you to pause the screen and write down what you've been listening to and watching. And then when you're ready, press play again. Okay, everybody should be with me now. We're going to go to the next one. It says 7 times 4. 3. So number 3 on our paper, instead of listing the multiples for 3, we're going to probably need to list the multiples for 7, or we could list the multiples of 4. Well, I know my 4s, but in room 9, we may not know our 7s just yet. So we're going to skip count by 4s. Mary had a little 4. Oh, we did it earlier on our paper. Go back up. Mary had a little 4, 8 and 12, 16, 20, 24 and 28, 32, 36. Mary had 40 lambs, 44, 48. So I just needed to add to it. If your paper was too busy to add to it, that's okay. You can just use mine and it'll be all right. It's just practice. So we needed 4 times 7, which is the same as 7 times 4. So 1, 2, 3, 4, 5, 6, 7. 7 times 4 is 28. So if 7 times 4 is 28, then 4 times 7 is 28. And 7 times 4 is 28. And when we can multiply factors in any order, we are proving the property of commutative property, which means they can flip-flop and be in any order. All right, the last one is another unknown, and it says 6 times something is 36. Well, by this point in the year, everyone has been working on their 2s, 5s, and 10s. So we know our 5s. So if I think about 6 times something is 36. Well, I know 6 times 5 is 30. So 6 times 6 is 36. And you're probably thinking, what? No song? Actually, there is a song. So slide your paper up, and I'm going to try to sing it really slow. So, oops, I grabbed this out of the scratch paper bin. Somebody had wrote a little something on it. So slide your paper up, and I'm going to sing slow, and you're going to write them down with me, okay? B-I-N-G-O, 6, 12, 18, 24 and 30 and 36, 42, 48, 54 and 60, 66 and 72, and that is our 6s. And so then I can see right here, 36 is 1, 2, 3, 4, 5, 6. So 6 times 6 is 36. All right. So how do you feel about that? Pretty good? Okay, let's go to the next slide. How much does this sheet of stamps cost? Pause the video and try to figure it out all on your own. I'll give you a hint. You're using the associative property. You're multiplying 3 numbers. What 3 numbers? Pause the video. Okay, I'm guessing that you're ready to show me what you know. So I'm going to slide this over just a tad. Okay, and hopefully you can see this. I know it might be small on your screen, but when I'm looking at these, I see 2 rows of 4. So 2 times 4 times 10. So for number 5, 2 times 4, because there's 2 down and 4 across, down and over, down and over. And then there's 10 cents. Or they're each 10 cents. So times 10. So now what I'm going to do is I'm going to make this bigger. Make sure you can really see it go. 2 times 4 times 10. So we can multiply this in any order. We're going to show 2 different ways to multiply this. So we're going to say 2 times 4. 2 times 4 is 8. And 8 times 10 is 80. That was pretty easy. What if we did 2 times 4 times 10, and we multiplied 4 times 10. 4 times 10, do parentheses first. 4 times 10 is 40. So 2 times 40 is, double facts. 2 times 4 is 8. So 2 times 4 is 8. Then 2 times 4 tens is 8 tens. So our answer is still 80. And I said 2 times 2 ways, but we're going to do one more way. So for number 6, We're going to start with 2 times 10 times 4 because we haven't multiplied 2 and 10 together yet. So we wrote it a little different. 2 times 10 is 20, and 20 times 4. Well, what is 2 times 4? 8. That's right. And if 2 times 4 is 8, 0 times 4 is 0, so it's the 0 property. And we have 80, 80, and 80. Woohoo! Awesome. Okay, let's shrink this back in. Let's go to the next slide. We have some missing equation facts. We'll come back to those at the end. What equation matches this array? What equation matches this array? Try it on your paper right now. All right, did you try? Uh-oh. So when I click on my visualizer, I'll be able to bring it up. And I can see that there's 1, 2, 3 down and 4 across. So the equation would be, I'm running out of space, so I'm going to have to flip it over. Number 7. The equation would be 3 times 4, or 3 groups of 4. 3 times 4 is 12. Now, what if we made this into a set of stamps? For number 8 on your paper, draw a quick picture. And what I love about notebook paper is I can actually use the lines to make these stamps. So I have 3 rows, and then I just need to do 4. When you're making 4, what you can do is find half. That makes 2, and then cut it again halfway between this line and this line, and then halfway between this line and this line. All right, so now we have the same model here, and we're going to make it worth something. So I'm going to say 3 times 4 times, why don't we use the number, the multiplication facts that you're on? So if you're on 3s, you would put 3. If you're on 4s, put 4. If you're on 8s, put 8. So most of my students right now, because it's November, they're doing their 3s and 4s. Oh, 3s and 4s. So we're going to put the number 3. 3, 3, 3, 3 cents, 3 cents, 3 cents. All of those 3s. We have 12 3s. 3 times 4 times 3. 3 times 4 is 12, and 12 times 3. Well, I could skip count by 3s all the way up. I could sing my song. I could add 12 plus 12 plus 12 because that would be 3 groups of 12. That's the flipped property. But I know when I sing my 3 songs, I go 30, 33, 36. So 12 times 3 is 36. I'm going to check it with adding just in case I forgot my song, which I didn't. But if I did, I could check with adding. So 12 and 12 and 12. And then when I add 2, 4, 6, 1, 1, 1. What is 3? Oh, I said it backwards. 1 plus 1 plus 1 is 3. 36. So my answer checks. All right, my sweet friends. So if you need to, pause the video right now and you can go back and check and make sure that your paper looks like my paper before you turn it in. We are going to go right back to our slideshow so that you can see those facts that we were working on. Oh, these are some good ones. These are true or false. So the way this works is 9 plus 5 is the same as 10 plus 4. And you have to decide, is that true or false? Let's do these instead of those equations. We could do equations any old time. Let's use some critical thinking and see if we can balance these equations, true or false. So I'm going to pull my visualizer right back up. I'm going to slide it over. And number 9, I'm just going to write the facts out really quickly. 9 plus 5 is the same as 10 plus 4. True or false. Second one was 9 minus 5 is the same as 10 minus 4. Then I've marked true or false. And the last one, 9 times 5 is the same as 10 times 4. I'm noticing a pattern. We're using 9 and 5 on one side and 10 and 4 on the other. Let's see what we have. 9 plus 5. 9 plus 5 is good, 14, which is the same as 10 plus 4, 14. So this one is true. All right, let's look at the next one. So if it worked for adding, let's see if it works for subtracting. 9 minus 5. So I'm going to say, put the big number in your head, 9, count back. 8, 7, 6, 5, 4. 4 is the same as 10 minus 4. 10, 9, 8, 7, 6. 6. Is 4 the same as 6? No. So if you're subtracting, it doesn't work. It's false. And so we're going to put a slash through the equal sign because that tells us that it is not equal. All right, let's look at the last one. I know that 10 times 4 really quickly is 40 and 9 times 5. So skip count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45. Did you say 45? Good. 45. Is 45 the same as 40? No. So it is false again. Okay. So I want you to think about, why did it work in this problem, but not in these two? If there's time, you can turn and talk to your partners in your group and see if when they're done. Don't interrupt them if they're not finished with the video, but you can turn and ask them what they think. Why does it work in adding and not when you subtract or multiply? All right, and if there's still time, you can go and right now, the picture's on your screen. You can solve these equations until it's time to rotate. Thanks so much for working hard today, and always stay curious and learn a lot. See you soon.